Good morning. Can everybody hear me in the back? Okay. Well, since Richard introduced me, I'll just proceed. This first presentation is Good Housekeeping Measures Part 1. These are some of the topics we're going to go through. Part 2 will be in the big room following this. Let's talk about concrete first. Washout water is hazardous. It contains toxic metals. It has a pH of 12. Drano is 13.5. Per EPA, if you have waste concrete, it goes while it's wet into the concrete washout, not left on the ground to dry. You say, well, I just put it beside it for the sidewalk. It doesn't matter. We have to pollute by putting the concrete in the formwork for the sidewalk. We do not have to put another blob beside it. That's called minimization of pollution. One of the things you got to look at, and we'll give you some examples of this, is watch out for any leaks. You should only fill them 75%. You need some freeboard in case we get one of our sudden rains. The first thing you need to do is choose your container. There are a lot of commercial washouts out there. There are also a lot of ways you can build your own. You need to consider size, and above all, consider they may leak. These are some examples of commercially available washouts. Now I put these two on the bottom in there just to show you there's other stuff out there. The contractors that use these only used them once. The one on the left, that's actually got a plastic liner and the outside is cardboard. It does not work well in rainy areas. On the right, that's PVC pipe. Exterior is heavy-duty plastic with interior liner. They said that was more trouble than it was worth. But you've got these big roll-offs, you've got the feed troughs, and of course the ever-present kiddie pool. You can build your own. You know, a lot of companies build their own boxes, do the in-ground. This one down here was a contractor built, but that liner was actually manufactured on the mainland for a specific purpose. Overpour, and I'll talk about that a little more later, what you can do for that. When I go out to a site I'll check the construction of the washout first. I will look at the capacity with what you're doing. I will definitely look for leaks. And as I walk the site, I'm looking for waste concrete or washout. Both leave very evident telltale signs. With construction, if you're doing an in-ground, the bottom sheet of plastic needs to be one sheet. You cannot overlap it. If you overlap it, the minute you put the fluid in there, it's going to run in between the sheets, such as right here. And in this one shows you what happens because it was built above ground. This is all wash water that leaked through the earthen dike. Capacity. The one on the left, that was only 2 of 5 kiddie pools on the site. If you think you have enough, add some more. Even these big commercial washouts, if you do not plan, you can fill it over capacity. Stuff leaks. The commercial washouts, you'll notice there's a line of caulking around where they open the back gate. Well, a lot of them tend to leak. Job boxes leak even when they've lined them with 3 layers of plastic, because when the concrete truck driver pulls up, he puts a chute up here and drops it down there, creating pukas in the plastic. Kiddie pools only survive one use. If you're planning to reuse your kiddie pools, line them with plastic, one sheet. and you might be able to use it for a second time around. Best thing to do is build some secondary containment underneath your washouts. That's not a requirement, but trust me, it'll make cleanup a lot easier. And it's simple. Roll out some plastic, stick some 2x4s, biosocks, even rocks under it to create a pooling effect. If you're doing an overpour, because you're doing a drill shaft, line around the bottom of it with plastic. Attach it to your structure, you know, the exterior of it. In this case, for those of you who know me, that would be a good use for duct tape. That way, when it hits the plastic, you don't have to worry about cleaning it up right away. You can allow it to dry. Saw cutting. It leaves trace. No matter what you're doing, I can tell whether or not you vacuumed. Any inspector can do so, because you'll see the evidence of vacuuming. If the fines per the manual are supposed to be moved by vacuum. Or you can sweep them up and carefully pick them up. If you're doing dry cut, use water to prevent the big plume of dust. And those of you who are involved in the safety community will know that with concrete now, you need to do wet cut, respirators, whole 9 yards for silica. You need to contain the fines and dispose of them properly. When I inspect, I look for trace, I look for adequate cleanup, and if I see a dust cloud, depending on what they're doing, I'll see if they're using water or if they put the filters in the vacuum. 2 examples of trace. This one on the right, that was a simple coring sample. There was no attempt to vacuum on that particular site. It ran into the gutter. It's a good thing there wasn't a drain inlet close by. And I can tell you on a city project, DOH had creamed a contractor for just this thing. On the right, you see those little ridges? That tells me nobody even attempted to sweep up. When I say put the filter in the vacuum, on the left, that's a little smokestack made out of vacuum parts. If you're vacuuming the fines, if you don't have the filter, you have essentially not done anything except spread them around. This guy in front is spraying the dry cut in the back. You notice there is no cloud of dust. Here's a couple examples of inadequate cleanup. They actually swept everything very nicely. They put the fines in the plastic. They're halfway there. They didn't close up the plastic. It's sitting in a rainy area and it's on a slope. Here they swept up again, but left it off the edge, so the next time it rained, you have this trail of where the water ran through the pile of fines. On the bottom 2, see that little guy right there? That's a vacuum. They vacuumed up the fines, but didn't contain them when they dumped the fines right off the end of the bike path. Okay, when I look at hazardous material, I'm looking at, we're going to talk about labeling, the types of chemicals, coal patch and waste asphalt also fall into the hazardous arena, and some other things. Per OSHA, every container must have an appropriate label on it. You need to have secondary containment for hazardous material, and it should be the appropriate size. Now, size doesn't mean it contains everything in the hazardous waste containment. It must be able to contain your largest item in that. If you have metal containers on a site, regardless of whether they're hazardous or not, they should be undercover or stored on an angle so rainwater does not pond on top of them. If placing material in a secondary containment is a common occurrence, unless it's in a spray can that the guy that's spraying the concrete curing compound on the fresh concrete, it must have a label. Here's two examples of inadequate labeling and correction. This one up here actually had the label of what it was on the container. It was Flexolith Ready Pack 3-part unit. So I said, okay, what is it? Nobody could tell me. And if you're in the safety, you know that's not good either. There was no product information. So they opened up one of these containers and found out it was 3 components. And they all had the hazardous material label on them. So their solution to that was they at least put the pictographs on the exterior container and moved it to their storage area. If you think about it, one of those could get dumped into your trash bin or kicked into a stream, and you'd have a real problem on your hand. This one, there was a pallet of retarder that was brought out to the site. It was a whole pallet full of them. The only thing on the container was retarder was written in a black Sharpie on top of the lid. So the contractor was able to reproduce and put a label on it. When I say secondary containment, when you bring a product out to the work site, you should stick it in some sort of containment. A good example is they brought a barrel of concrete cure out for use, set it on the pallet, had the pump in it to put it in the secondary containment, and that's just a small portion of the white puddle that was under that containment. Yes, they covered it over, but I peeked. Some contractors will use a rubber pallet that has a self-rising float on it. That's appropriate containment. However, it doesn't work very well if you set a container on top of the float. If you're using any sort of containment, make sure the barrel sits over the containment and doesn't drip off the edge. And this is why the metal containers are very important on the site. This barrel had stuff in it. I don't know what it was because the label washed off. These are some examples of good containment. There is actually a berm along here. It doesn't show well in the picture. But these are all metal barrels. They're stored under the viaduct, which can be your cover, and they were in containment. The one on the bottom was a contractor constructed containment for the concrete cure. And actually right here, they had a little bitty trough with some kitty litter in it. Thought that was pretty good. There are also commercial products like that. Other storage options, static containment. These things have a berm around the edge of it, and this was lined with plastic and fabric with a berm in front of it. Again, metal containers need to go in storage or under plastic to prevent rusting. Other contaminants, coal patch and waste asphalt. They're both petroleum-based products. You put it on the ground, got a problem. You're leaching petroleum into the ground. The top picture with a load of coal patch there could have been prevented very easily by a little scheduling and having somebody on site when that load arrived. Instead, this contractor had to pick all that up and move it again. Right now, we keep hitting the old railroad ties here on Oahu every time we excavate for a road. These things are impregnated with creosote. The other thing is foam poles. They need to be wrapped to prevent contact with rainwater and treated as hazardous material. On the bottom left, this actually has triple protection. All those bags contain lead contaminated soil. They're sitting on a concrete pad with a raised lip. They're in the super sacks and they're covered. Let's talk about construction entrances and alternatives. 3 to 6 inch rock, not 1 to 3. There is no place on Oahu where you can use 1 to 3. The city has changed their requirements as of November 2011. They are also requiring 3 to 6. The size is stipulated in the manual is 30 by 50. Now you say, well, my site's only 30 to 50. You can adjust the size of your concrete or your construction entrance to fit the site. You should line that out in the SWIP. You need fabric under rocks. Inspection 101 tactics. Leave a piece of the fabric poking out. It's a real pain in the butt to have to dig down to prove that you've got fabric under that rock. Once you get fines in your entrance, you need to look at refreshing the rock or applying more rock. You cannot use it for a tire washing station. You do not have the sump. If you're using a commercial alternative, and I'll show you some examples of those, you comply with the manufacturer's installation instructions. Okay, the top two, this one and this one, shows the genesis of a rock entrance. It's dug down, lined with fabric, then the rock brought in. The one on the bottom here, the rock is too small. When I talked to the contractor about this, he told me he called one of the rock distributors and said, I need rock. And he said, what do you need it for? Construction entrance. That's what he sent him. So you need to stipulate your rock size. Here's two alternatives that are most common around here. The top is a Geoterra mat. And if you want some more information on that, they've got some samples out there. You install per manufacturer specs. There's fabric under that mat. It's bolted together. It's bolted to the ground. Easy to install. And I asked a contractor who did an analysis between this and the rock entrance. I said, did you compare costs? And his estimate, and this is a swag, scientific wild ass guess, was that labor to put in, take out, and materials, a rock entrance was $8,000 to $10,000. By using the same with Geoterra, he was looking at $6,000 to $8,000. The difference is you can pick this up and take it with you. The bottom is track out plates or rumble strips, and there are all sorts of varieties of these. If you're going to use one of these products, you should have it in your SWIP. When I talked about tire washing, you do not use your entrance as a wash rack. Now the one on the top, this was a contractor constructed tire washing station. And by the way, both these should be used in conjunction with a regular construction entrance. But basically they put the track out plates on top of plastic and it was dug out a little bit underneath. It slopes down into a sediment trap for anything that washed off. The bottom, that's on a very big project, and they have the sumps and it leads to a construction entrance. And when I say you need to use it in conjunction with the construction entrance, it's because You wash the tires, you need to go over something where you're not going to pick up mud again. Otherwise, it did you no good to wash the tires. Do we have any questions?